So today we're going to cover chapter 6, section 4, and today we're going to look at shifts of the sine and the cosine graph. So we're going to be shifting them vertically and horizontally. So last week we took a look at the normal sine curve graph. Remember the normal sine curve graph when there's no amplitude or no speed change, or it's always going to start at 0, 0. Even if there were an amplitude or a speed change, the sine curve is always going to start at 0, 0. The only time it's not going to start at the order pair 0, 0 is when we have a phase shift. And also if we shift it up or down. So normally the sine curve starts at 0, 0, and then it goes in the direction of the amplitude. If there is no amplitude, then it's going to just go up towards +1. Then this was the cosine graph. Remember, the cosine graph always starts at 1 unless there's an amplitude. Then it would start at the amplitude. And remember, the amplitude is going to be the number that's in front of either the word sine or cosine. So here's where we define what an amplitude and a period was. So again, the amplitude is this number that's in front of either sine or cosine. And then the B value here, this is going to be describing our period length. And normally the cycle for cosine and sine is done in 2 pi, but when you have a number, a B value that's greater than 1, it's going to go faster. When it's a fraction, a number less than 1, then that is going to be a little bit slower. And we always take 2 pi and we're going to divide it by that B value. Then in order to get our coordinates along the x-axis, we're going to take the answer we got from doing 2 pi divided by b, and then we break them into 1/4, 1/2, 3/4, and then finally that last one is the period length. The amplitude just gets labeled along the y-axis. Let me quickly go through one of the examples I did last week. Now this one has both an amplitude and it's got a speed change. So remember, this number that's here, this is my amplitude. And remember, the amplitude is just going to get described or labeled along the y-axis. So for example, let me go ahead and put my y-axis here and my x-axis. So all I would do here is, because it's got an amplitude, I don't have to go 1, 2, 3, 4 and then put all those little dashes there. I could just say this is 4 and -4. So the amplitude just gets labeled along the y-axis. Now for this B value, which is 2, this is going to tell me if my graph goes faster, my cycle goes faster or slower. Again, when that number is greater than 1, it'll be faster. So we took 2 pi and we divide that by that B value. So 2 pi divided by 2 is just going to give me pi. This is how fast my cycle can be completed. Now it's going faster. It usually took 2 pi. Now I can do it in just pi. And then remember, we took that pi value and then we're going to break it into quarters. So we multiply it by 1/4, 1/2, 3/4, and then also 4/4, which is just what we had originally. So this becomes pi over 4, pi over 2, 3 pi over 4. Now these are going to be the labels that go along the x-axis. So, and I'm going to evenly space them out. So I could put pi over 4, pi over 2, 3 pi over 4, and then finally the pi. The left side of the y-axis is the exact same values here, except for they're negative. So this would be -pi over 4, -pi over 2, -3 pi over 4, and then -pi. So this is what I want to see in your work tonight. When you're doing the homework, I want to see all these calculations and graph it by hand. And then once you do all the work in Notability, then you'll pick the multiple choice answer. So remember, the sine graph always starts at 0, 0. And then from there, I go to the direction of the amplitude. So I'm going to go up to positive 4 at the pi over 4. Then again, it's like a pattern. The highest it gets is 4, so now I got to go back down. So then at the pi over 2, I'm at the x-axis. Then at the 3 pi over 4, I'm down here at the negative 4, and then back to where I started. And again, don't make zigzags, add little bends to this because it's a wave. And then repeat the pattern on the left side. And again, add little bends. And there is your sine graph with an amplitude and a speed change. This is what we did last week. Then I also did a cosine example, and then another sine example, and then here brings us to where we left off. So these are the vertical shifts. So what we're going to be doing is we're going to graph the same way we just did, but then once we get our graph, we're just going to shift all the points that we just graphed and then shift them all up. So whenever it's a vertical shift, something is going to be either added or subtracted from sine x or cosine x. No parentheses around it. Now, when it's adding something, this is a shift up, just like you would think, going up towards the positive numbers. When it's subtracting a number, this would be a shift down. So the top one is shifting it up 2 units, and the bottom would be subtracting 3, so it would be down 3 units. Now, in the homework, you might also see equations with the number in front of sine x or cosine x. This is the same thing as this. It's when there's parentheses, and then that's when we're going to shift it left and right. So no parentheses, just something being added or subtracted to sine x or cosine x. That will be the shifts up and down, vertical shifts. So let's try an example. So they want me to graph sine of 4x plus 1. So this plus 1 here, this is telling me I'm going to be shifting. So it's a shift up 1 unit. I'm shifting it vertically. Now, here, the 4 in this problem is the b value. So remember, this is going to be the speed change. When it's greater than 1, this is telling me my graph is going to be super fast. It's going 4 times faster. So I take 2 pi. I'm going to divide it by that b value, which is 4. So 2 pi divided by 4. I could simplify that. And now I'm going to be able to complete my cycle in pi over 2. So before, it almost took, if you think about 2 pi being 360 degrees, it took a whole, trip around the whole unit circle to normally complete it. Now I'm doing it in pi over 2, which is 90. So this is super fast, 4 times as fast. So now I take that newly found period length, and I'm going to break it into quarters. So pi over 2 times 1/4, pi over 2 times 1/2, pi over 2 times 3/4, and pi over 2 times 4 over 4. So here I get pi over 8, pi over 4, 3 pi over 8, and then 4 over 4 is just 1, so pi over 2. So these are going to be my labels that'll go along the x-axis. Notice this one did not have an amplitude, so my labels along the y-axis are just going to be 1 and -1. So let me go ahead and create my x-axis here, and then my y-axis. And again, I did not have an amplitude number, so I'm just going to put a 1 here and a -1. And now I'm going to go ahead and label my key points. I'm going to be labeling, so I'll go pi over 8, pi over 4, 3 pi over 8, and then lastly pi over 2. And again, when there is no horizontal shift, we just take those same coordinates we just got and we put them on the other side with a negative sign. So it's like a reflection. So pi over 4, 3 pi over 8, and then pi over 2. So now, still the sine graph. So I'm going to be, what I'm going to do first is I'm just going to graph it, this one first, with these coordinates. And then I'm going to take all of my blue dots. I'm going to do it in blue first. And then I'm going to shift them all up 1 unit, and that'll be my final graph. So my final graph will be in red. So let me go ahead and put dots, the blue dots. So sine always starts at 0, 0. And then it's going to go up to the amplitude, which I don't have. So it goes up to +1, and then back down, and then down again, and then back here. So I got this little wave going on. And then over here, back up, and then down again. Now, let me add another little mark here, because now I'm going to take all these blue dots, and I'm going to shift them all up 1 unit. So I take the negative pi over 2, and it's going to go up 1, up 1. Just move everything up 1 spot. And now connect. This is a vertical shift of 1 unit up. So we're going to graph just like we did, and then we shift them all up 1 unit. This time, it's a -1, so this is going to be 1 down. Now, my b value is this pi over 4. It's the number in front of x. So this is my b value, and remember, we do 2 pi divided by b, so 2 pi divided by pi over 4. So remember, this mean fraction bar here, this is like our division. So really what we're doing here is 2 pi divided by pi over 4. Keep change, flip it. The pi's cancel. And then now I'm just left with 2 times 4, and it's 8. So I don't have any pi, but again, these are just going to be labels along the x-axis. So now this is my period length. It's going to be done in 8. So 8 radians here. So it's going a lot slower, so a little bit more than the full circle and past it, because you figure the full circle is a little bit more than 6 radians. So then now what I'm going to do is take that 8, multiply it by 1/4, 1/2, 3/4, and then again 4 over 4, which just gives me the 8 back again. So 8 over 4 simplifies to just 2. You could simplify diagonally if you want, or do 8 over 4 and then simplify it, either way. And then simplify this one, becomes 4, simplify 2, 1 and 2, and this becomes a 6. So these are the labels along the x-axis. This one did not have an amplitude, so I'll just put 1 and -1. So let's go ahead and get your x-axis here and your y-axis. So I have 1, and then I have -1. Since I'm shifting it down, I'm going to add a -2 here as well. And then you'll just put your labels here, 2, 4, 6, 8. Over here will be -2, -4, -6, -8. Remember your sine graph, so I'm going to first graph just this, and then the final graph will be with the shift of 1 unit down. So I'm going to go ahead, I start at 0, 0, it's a sine graph, and then I go up to the amplitude, which it doesn't have one, so I go up to +1, and then I go back down again at the 4, and down to the, and here, and again, add your little bends over here, back up, and then down again, same level you started at. So now I'm going to take all of those blue dots and shift them all down 1 unit. So here. Just go down one spot each time. And now connect them. And there is your shifted graph. So it's going slower, and it also got shifted vertically 1 unit down. Now we're going to do the horizontal shifts. This is the more challenging of the shifts. So when we're graphing with a phase shift is just graphing or shifting our graph horizontally, left and right. And what's going to happen here is it's going to be backwards of what you think. Now, I know there's a lot of words here, but basically this is what it'll look like. Y equals sine, and they'll have parentheses. And then it'll have your x. And again, I'm not going to give you a phase speed change, so it'll just be the x. And then it'll have something added or subtracted to that x. And when it's in parentheses, it's backwards of what you think. So you would think minus pi over 4, I'm going to shift left, but it's backwards. The minus means we're going to shift it to the right to pi over 4. And then if it were a plus sign, let's say it's cosine and x plus pi over 4, this would be a shift to the left. So I would actually be my starting point would actually be negative pi over 4. So when it's shifted to the left, we're getting into the negative values to the left of our y-axis. So remember, pi over 4 is 45 degrees. So really, the first one would have been shifted and starting now at 45 degrees, or pi over 4 to the right, or if it's to the left, it would be starting at negative 45 degrees or negative pi over 4. But we're labeling everything in radians. We're no longer using the degrees. So this is some steps to graph with a phase shift. Instead of finding the quarters, we're going to space our key points 90 degrees or pi over 2. Each one of the key points will be 90 degrees or pi over 2 apart. So what we're going to need to do is we would take our starting point, and to get the 4 points to the right, we're going to add pi over 2. To get the 4 points to the left of the starting point, we subtract pi over 2. So it's no longer going to be like a reflection. So we're going to need to do 8 different calculations to get our 8 key points. And it may look lopsided depending on where we're starting. And I'm going to show you what that means. So let's take a look at an example. So here's my first example. Notice the number in front of x here is a 1. So my b value equals 1. Again, I'm not going to give you a phase shift and a speed change. So my b value is 1, so my normal cycle here would have been taken in 2 pi. However, we're going to shift it so it's going to look like it goes beyond 2 pi when I make my labels. Okay, so this is backwards of what I think. So this is going to be a shift to the right, and I'm going to be starting at pi over 3. And if you think about it, you memorize that unit circle, pi over 3 is 60 degrees. So now I'm not starting at 0, 0. I'm going to be starting over at 60 degrees, or pi over 3. So now let's get our key points. I'm going to take this starting point. So I start at the pi over 3. So I'm going to take pi over 3, and I need to add pi over 2. I'm spacing them all 90 degrees or pi over 2 apart. I need to find a common denominator. My common denominator here is going to be 6. So I'm going to change my fractions so I can see that I'm going to multiply 3 by 2. So this will become 2 pi over 6, and then the pi over 2 becomes 3 pi over 6. So from here to here, all I did was change it and give it a common denominator. So my first key point after the starting point is going to be 5 pi over 6. I need to find 4 of these. So now I'm going to take the 5 pi over 6, and I got to add another 90 degrees or another pi over 2. So again, remember, pi over 2 with a common denominator is 3 pi over 6. So that's what I'm going to add here. So I don't have to go back and find the common denominator again. This gives me 8 pi over 6. Now when I go to label it, I'm going to reduce this fraction, 4 pi over 3. Now to get my next point, instead of using the reduced fraction, I'm going to go ahead and take the unreduced. So I already have my common denominator. Oops, over 6. This gives me 11 pi over 6. I need to do it one more time because I need 4 of these. So 11 pi over 6 plus 3 pi over 6 is going to give me 14 pi over 6, which will give me 7 pi over 3. So now, these are my 4 points. So these are my 4 key points to the right of pi over 3, my starting point. I now need to find 4 key points to the left, and I can't just make these all negative. Now I have to subtract pi over 2. So these are more work. Okay, so let me go over here now, and I'm going to take the pi over 3, and I'm subtracting pi over 2 4 times. So again, my common denominator was the 2 pi over 6 plus minus 3 pi over 6. This gives me negative pi over 6. And then I take that negative pi over 6, subtract 3 pi over 6 again. Negative 4 pi over 6. That will reduce to negative 2 pi over 3. And then again, take the unsimplified, so the negative 4 pi over 6. Subtract 3 pi over 6 again. Negative 7 pi over 6. And then I need 4 of them, so I got to do it one more time. So negative 7 pi over 6 minus 3 pi over 6 gives me negative 10 pi over 6, which reduces to negative 5 pi over 3. These are now the 4 points to the left of the starting point. I'm just gonna come below it, I think. I'm not gonna use the squares because I wrote all over that place. So let me just make an X and a Y axis. And again, you can do this. You don't have to do it on graph paper. Just make sure they're evenly spaced. So I don't have an amplitude. So I just put 1 and negative 1 here. Now, remember, I'm starting here at pi over 3. And if you think about it, pi over 3 is 60 degrees. So I want to sort of space these and space them out so it looks logical. So my next one, when I added 90 to 60 degrees, that gave me 5 pi over 6. And if you think about it, that's 150. And then my next one, evenly spaced out, this gives me 4 pi over 3. And then about the same space, 11 pi over 6. And I got to do it one more time because remember, this is where we're starting. And I need 4 to the right, 4 to the left. So the last one is the 7 pi over 3. Now, the one that's on the immediately on the other side, remember, this was negative pi over 6. And remember, pi over 6, this is negative 30 degrees. So you see how this little space here, it's about the same size as this space because they're all 90 degrees. So the key mistake that I'm going to see on the test is there is no stopping point this time on the y-axis. I'm going from the pi over 3 to the negative pi over 6. So the biggest mistake I'm going to see are people are going to put dots on the y-axis when I go to graph this, and there is no starting point or stopping point in this particular graph because I'm jumping from negative pi over 6 to pi over 3. But let me go ahead and finish labeling. So again, 4 key points to the left. All right, so let me make this about 90 degrees away from that. And this is negative 2 pi over 3, negative 7 pi over 6, and then negative 5 pi over 3. So now remember, sine normally starts at 0, 0, but we have now shifted it to the right. So now instead of starting at 0, 0, I'm going to be starting it at pi over 3, comma 0. So this is going to be my starting point, not 0, 0. And then normally sine goes to the amplitude, but there wasn't any, so it goes up to 1 at the 5 pi over 6. And then it goes back down at the 4 pi over 3, down here, and then back to the level we started at. So here is a phase shift, now starting at pi over 3 instead of the y-axis. Now, my next dot is not on the y-axis. It is at negative pi over 6. So it's actually down here. So it does cross it, but the dot is at negative pi over 6. And then back up here, here, and then back again here. Notice my graph looks a little lopsided. Okay, notice there are 5 key points over here, but only 4 over here. But what you have to remember, out of these 5, this is the starting point. So really we have 4 here and 4 here, because the right side of the y-axis actually includes my starting point. My next one is a cosine graph. This one actually has an amplitude. And again, this amplitude is what's going to get labeled on my y-axis. Notice again, backwards of what you think. So you would think this would be going to the right, but this is going to be starting to the left at pi over 4. I'm shifting it over pi over 4 to the left. So really my starting point is going to be at negative pi over 4 when I shift it to the left. So now, again, I take that starting point, the negative pi over 4, and I'm going to find 4 key points to the right of it by adding pi over 2. Again, I need to find a common denominator. My common denominator is going to be 4, so the first fraction is good, but the second one becomes 2 pi over 4. So essentially, this is what I'm adding each time, because it's equivalent to pi over 2. So once I add this, my first key point to the right will be pi over 4. And then I'm going to do it again. Add the 2 pi over 4. 3 pi over 4. Add it again. 5 pi over 4. One more time, because I need 4. 5 pi over 4 plus 2 pi over 4 gives me 7 pi over 4. These are the 4 key points to the right of the start. Now I'm going to do the same thing and subtract pi over 2. So again, from my starting point, the pi over 4, I'm subtracting pi over 2, which remember is the 2 pi over 4. So once I subtract, my first key point to the left will be negative 3 pi over 4. Take that value, subtract another 2 pi over 4. Now notice this one, it looks symmetrical. Notice my points are ending up being the same numbers but with a negative sign. But I do need to take this left side and go one additional time. So 5 pi over 4, 2 pi over 4, 7 pi over 4, and then one more time, negative pi over 4. So these are the 4 key points to the left. So now let me set up my x and y axis. Okay, so it did have an amplitude. So if you want to put a 1 and a 2, you can, but really all you have to put is -2 and +2. And then let's start labeling. So we've got pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then I need to go and label the left side. Now remember, this one right here is my starting point. Actually, let me put them a little closer, because they're 90 apart. So this is actually negative pi over 4. And let me just shift this one a little bit. Okay, so remember, in between each one of these is 90 degrees. So 90 here, here, here. And remember, pi over 4 is 45. So if you think about this, this is negative 45, positive 45. So the distance in between there is 90. And then the same thing on the other ones. All right, so now let me keep going here. And then now I have negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4, and then finally negative 9 pi over 4. And again, remember, it's sort of looking lopsided, but remember, this is where we start. Remember, the red that I just highlighted, this is where we're starting. So we actually have 4 to the right, 4 to the left. So the cosine graph, remember, normally starts at 1 on the y-axis, but we're starting at the shift, and we start at the amplitude. So I'm actually going to start at +2 and at the negative pi over 4, because I'm starting to the left. And then now, I don't put a dot on the y-axis. I need to put my next dot 90 degrees or pi over 2 apart. So my next stopping point is at pi over 4 on the x-axis. And then down here, and then back up, and then back up to the level that we started at. So here, 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 and here. And then the next one this way would be here, and then here, here, and then back up to the same level. So for this next example, it has an amplitude of -2. So again, that's going to just be the labels along the y-axis. So +2, -2. And again, remember, for these shifts, when it's in the parentheses, this is the horizontal shift, backwards of what you think. So this is going to be a shift to the right, and we're going to start at positive pi over 2. So again, I need to get the key points along my x-axis. So I'm going to go ahead and take pi over 2 and add pi over 2, because I'm spacing all of my key points 90 degrees or pi over 2 apart. This will give me 2 pi over 2, which is just going to simplify to pi. Now when I go to get my next key point, I'm going to take the unsimplified fraction, the 2 pi over 2, add another pi over 2. This will give me 3 pi over 2, 3 pi over 2, plus pi over 2 will give me 4 pi over 2, which gives me 2 pi. I'm going to do it one more time, because we want 4 key points. Again, take the unsimplified fraction, and we get 5 pi over 2. So these are going to be the 4 key points that are to the right of the starting point. So now I'm going to also take my starting point, and I'm going to subtract pi over 2, and I get 0. This time there is a stopping point on the y-axis because I just calculated 0. So it does stop on the y-axis. And again, I'm going to take 0, subtract pi over 2, get negative pi over 2. Need to do it 2 more times. Negative pi over 2 minus pi over 2. Negative 2 pi over 2 equals negative pi. And again, take the unsimplified. So I have a common denominator, negative 3 pi over 2. So these are the 4 to the left of the starting point. So let's get those key points labeled along the x-axis. So 1, 2, 3. And one more. So this is pi over 2, pi, 3 pi over 2, and then 5 pi over 2. And then in the other direction, same thing. Negative pi over 2, negative pi, negative 3 pi over 2. And again, it's sort of looking like my graph is lopsided, but it's not, because again, remember, this is where we're starting. So this is the sine graph. Remember, sine normally starts at 0, 0, but in this case, we've shifted to the right. So we're going to start at pi over 2, comma 0. And then from there, we go in the direction of the amplitude. So over here at pi, it's down at negative 2, then back up and up again. So here is. Now when we go in the other direction, remember we calculated 0 here. So 0 is a stopping point. So right here on the positive 2, back down to the axis, and down and back up again. And there is your graph with an amplitude of negative 2 and a shift to the right to pi over 2. Let's try one last example. Cosine graph. Again, we have an amplitude here, and we also have a shift. And pi over 12 is actually 15 degrees. But again, we're still just doing the same calculations. Again, it's minus, so backwards of what you think. So we're starting at pi over 12 to the right of the y-axis. So we would take pi over 12, add pi over 2. Again, we need to find a common denominator. That common denominator is going to be 12. So pi over 2 becomes 6 pi over 12. And then now we can add. And we get 7 pi over 12. And then I'm going to do it again because I need 4 key points. Add 6 pi over 12. 13 pi over 12. 13 pi over 12. Add another pi over 2. Which its equivalent fraction is 6 pi over 12, so 19 pi over 12. And again, I need one more because I need 4 to the right. So 19 pi over 12 plus 6 pi over 12 gives me 25 pi over 12. These are my 4 to the right. And now I'm going to do 4 to the left. So again, the pi over 12 minus pi over 2. And again, common denominator, pi over 12 minus 6 pi over 12 gives me negative 5 pi over 12. And then negative 5 pi over 12 minus 6 pi over 12 is going to give me negative 11 pi over 12. Negative 11 pi over 12 minus 6 pi over 12, negative 17 pi over 12. One more, negative 17 pi over 12 minus 6 pi over 12, negative 23 pi over 12. Now I have my 4 points to the left. Let's go ahead and set up our x and y axis with our amplitude along the y-axis. go ahead and make my x-axis and get my y-axis here. So again, it had the amplitude of a half. So 1/2 here, -1/2 here. And then now I can get my key points. I'm going to put my starting point, which is this pi over 12. And again, I'm spacing it 90 degrees apart. And let me put them a little closer. And then one more right here. It's kind of close. Okay, so this is 7 pi over 12, 13 pi over 12, 19 pi over 12, and this last one that is sort of crammed in is the 25 pi over 12. And then over on the other side of the axis, we have the -5 pi over 12, and then -11 pi over 12, and then -17 pi over 12, and then lastly, -23 pi over 12. So now this is the cosine graph. So remember, the cosine graph starts at the amplitude, but we're also starting to the right. So I'm starting at pi over 12 at the 1/2 at the amplitude. And then at the 7 pi over 12, come down to the axis. Then here at the 13 pi over 12, down here to the -1/2, and then back up, and then one more time to the same level that I started. So here is my little curve. And again, I do not have a point on the y-axis. My next stopping point is this -5 pi over 12. And then down here, back up, and then back up again to where we start. And again, no stopping point on the y-axis for this one. And that is the graph of the cosine with an amplitude of 1/2 and a shift to the right to pi over 12.